Hello and welcome to a special edition of these online GoToMeeting videos for our Math 171 course. This video right here is exclusively for preparing for the midterm exam, which of course runs from Thursday, October 15th through Tuesday, October 20th. And I want to give you some tips as what to expect with the exam, the structure of the exam, and the nature of the exam, and also some specific pointers on things to review for the exam. Once again, we've got issues with the iPad functionality with the PC, so actually had an IT person who was supposed to come today and they couldn't make it, so once again I'm still not having my iPad. So I'm essentially going to be, although it's a video, it's essentially an audio type experience here for this particular lesson. So once again, this is exclusively in preparation for the midterm exam. And to start off, I want to let you know what to expect before you go to the Academic Success Center to take your exam. Please remember you're going to be allotted 2 hours. You have a 2-hour time period to take the exam, and you cannot take 1 hour and then come back another day and take another hour. You have to do it all at one time. You do have to bring a picture ID to identify yourself, so they will know who you are to let you take the exam. And you are allowed to bring your own calculator of any type whatsoever. You can bring your own calculator. And you're allowed to use a computer in the Academic Success Center. Our class has been authorized to use the computers there. So you will have a computer that you can use, not just for whatever you please, of course, but specifically you can use the computer for graphing utilities, like an online graphing calculator, something like Desmos, as we've used in some of our lessons here together. It's an excellent free online graphing calculator. You can use Desmos or anything of that nature that you prefer. But that's the only thing that the attendants and the proctors in the Academic Success Center will allow you to use the computers for, just for that. You're not allowed to use your textbook or your any kind of handwritten notes that you may have been accumulating. You're not allowed to use any of those. They will offer you what you call scratch paper, extra blank paper, along with the test to give you more room to write on if you need it. Now for the test itself, it will have 12 problems on it. 6 of the problems are going to be from Chapter 1, and 6 of the problems are going to be from Chapter 2, those from that material. You must show your work on all the problems. Show your work. Don't just write down an answer. You have to show your work in order to receive full credit for each problem. There is also an extra credit problem at the end of the exam. After the 12 required problems of the exam itself, on the next page there is a single extra credit problem. It's worth up to 4 points, anywhere from 1 to 4 points, depending on how you do on that, of extra credit. And the very last page of the exam, following the extra credit problem, there is a formula page, which has some basic formulas out of the 2 chapters for your use during the test. Formulas like the slope formula, the point slope formula, the equation of a line, slope intercept formula, the equation of a line, standard form of a complex number, x-intercept notation, y-intercept notation, and the quadratic formula. So that's what's going to be on the handout, or the actually stapled to the back of the test, the formula sheet. So that's the format of the exam. Each of the problems counts the same. All 12 problems each count 8 points. They all count the same. No one problem counts any more than any other problem. So they all count the same. So if time, I don't think time is going to be an issue. I really don't. But if it were to be an issue, then do the ones easier to you first and accumulate the points and come back to the harder ones later. So what kind of problems can you expect to see on the exam? Well, what is going to be on here is what are really the important kinds of problems out of the two chapters. And listen along with me here. Unfortunately, again, I can't use the iPad. I can't run through anything with you on the screen, but at least verbally I can express to you the types of things you should be prepared for. So first of all, expect to be drawing some graphs on the test paper. For several of the problems, you're going to be required to sketch a graph of some equation or of some function. So of course you're going to do that most likely first on your graphing utility, and then draw the axes, the x and y axes, on the paper and sketch the graph. And as a reminder, anytime you sketch a graph on paper, drawing the x and y axes in pencil, you must show some kind of scale on the x-axis and some kind of scale on the y-axis. Of course, you put the little marks, but indicate whether each mark is for 1 unit or 2 units or 10 units or whatever. Some kind of scale should be shown on each axis. And with these graphs, along with sketching the graphs of the equations and functions, you will also be asked to identify and state certain information about the graphs. For instance, you may be asked to tell the coordinates of the x-intercepts and the y-intercept. And when I say tell the coordinates of x-intercepts and y-intercepts, I do mean to put it in point notation, like the x-coordinate comma the y-coordinate inside parentheses. So it's going to be an actual point with an x and y coordinate for both the x-intercept and for the y-intercept. And you may also be asked to tell the domain of a function. The domain, of course, is the set of x values that the function can attain. Sometimes it's just all real numbers. Like if you had y equals x squared, then the domain would be all real numbers. X can be any number, so it's fine to say that. You can say all real numbers, that's fine. Or you can put in interval notation, parentheses, negative infinity, comma, infinity, and the parentheses. Interval notation is fine, but it's not required. If you express in words accurately what the correct domain is of a function, that will be fine. Remember limitations on domain. For instance, if I gave you a function like f of x equals 1 over x, x can be any number, positive or negative, but it cannot be 0. So with f of x equals 1 over x, x cannot be 0 because you cannot divide by 0. It creates an undefined expression. So the domain would be all real numbers except 0, for instance. And you can do that in interval notation if you wish. You may also be asked, after you graph a function, you may be asked to tell what are the open intervals on which the function is either increasing or decreasing or constant. And that must be in interval notation. And since whenever we speak of a function being increasing, decreasing, or constant on a certain interval, it is always over what we call open intervals. So you will always use the rounded parentheses on both ends, both sides of the interval, and you will not be using any square brackets for those kind of intervals. So just parentheses around the endpoints. You should also be able to do arithmetic operations with functions, such as adding two functions together, subtracting one function from another, multiplying two functions, or dividing one function by another, and such as that. So if I give you f of x equals some expression in x, and g of x equals some expression in x, and then I ask you how much is f plus g of x, you should be able, of course, to add those together, simplify the algebra, and state the answer. Always, whenever you do problems like that, always simplify the algebra. Combine like terms. If it's a fraction, reduce it to lowest terms. Even if it's algebraic reduction of fractions, for instance, if you had x squared minus 4 over x minus 2, that's not fully reduced because x squared minus 4 in the numerator can be factored as the two parentheses x plus 2 times x minus 2, and then since you have the x minus 2 in the denominator also, the x minus 2 in the numerator and denominator would cancel, and so you would be left with simply x plus 2 over 1, which would be simply x plus 2. You should know how to determine whether two functions are inverse functions of each other. And the easiest way to do this, class, is actually using the definition of inverse functions as presented in the text. The easiest way to do that is to do a composition of one function with the other and then of the other with the one. Do two compositions. If you're given f of x and g of x as being two specific functions, for instance, then figure how much f of g of x is. That's a composition of the two functions. Figure out how much f of g of x is, and it should equal x. Exactly. F of g of x should equal x if it is actually for real, if the two functions are inverse functions of each other. And then do it the other way. Test out g of f of x, and if g of f of x also equals x, then you can make that statement and end up the problem saying yes, because f of g of x equals x and g of f of x equals x, then yes, it's true that these two functions, f of x and g of x, are inverse functions of each other. There's an example of this in example 3 on page 143 of your text. Example 3 in section 1.7 of your text. Exactly what I've just been going over with you. Okay, moving on to chapter 2. What should you be prepared for? You should know, of course, chapter 2 is all about solving equations and inequalities. So essentially, that's what you should be prepared for. The kinds of equations and inequalities that you saw in your homework problems and in the lab. So, for instance, and speaking of such, that the two labs that you had this the two labs that you had to do this for chapter 1 and for chapter 2 would be a good review. Those kinds of problems are going to be actually doing those problems was a good preparation for this exam. All right, but specifically, what kinds of equations should you know how to solve? You should know how to solve equations where you have algebraic fractions, such as if you had 2x plus 3 over 5x minus 4, and that equals 1/2, say. So you have this 2x plus 3 over 5x minus 4 equals 1/2. You have an equation with x's in it and fractions, and for instance, an equation like that, probably the easiest way to do that, since that's set up as a proportion, the easiest way to do that would probably be to cross multiply. Multiply the 2x plus 3 times the 2, and then the 5x minus 4 times the 1, set those equal to each other and solve for x. Sometimes you'll have more than one algebraic fraction in an equation, and it's not just a proportion. In that case, it's usually most often the easiest thing to do is to multiply the entire equation by the lowest common denominator of all the fractions. And so if whatever the lowest common denominator might be, if it's simply a number or if it's an algebraic expression. So, for instance, if the two denominators were 2x and 5x, the lowest common denominator then would be 10x, for instance. And multiply the entire equation by then 10x over 1, and all the fractions evaporate. And you have an equation in x with no more fractions, and you simply solve for x. Know how to do your basic operations with complex numbers as in section 2.3. You should know how to add two complex numbers together. You should know how to multiply two complex numbers. Or when I say add, you should know how to add and subtract. And you should know how to multiply two complex numbers and also how to divide one complex number by another. And please remember that complex numbers are typically in the form of a plus bi, where a and b are real numbers and I is the imaginary unit for the square root of -1. So a plus bi is the standard form of a complex number, and that's the form you should present all your answers in. Anytime I ask you to add or subtract or multiply or divide two complex numbers, your final answer should be simplified down to the standard form of a plus bi form. Remember also to divide one complex number by another one. You have one in the numerator and one in the denominator. So for instance, if you had 1 plus I over 5 minus 5i, then you would, to accomplish the division of 1 plus I by 5 minus 5i, you would multiply the top and the bottom of that fraction by what we call the conjugate of the denominator. And this is all in section 2.3, the complex number section. The conjugate of any complex number, a plus bi, is simply a minus bi. The only thing you change is the sign in the middle, the sign of the imaginary term with the I. So if we had 1 plus I over 5 minus 5i, the conjugate of 5 minus 5i is 5 plus 5i. So we would multiply the top and the bottom of 1 plus I over 5 minus 5i times 5 plus 5i over 5 plus 5i. And since you're multiplying by something divided by itself, you're simply actually only multiplying by 1, which is a legal move in math. It's not changing the value of it, it only changes the expression of it. And you will end up with an expression that no longer has I in the denominator. So you will get something in the a plus bi form. Be prepared to solve quadratic equations. Quadratic equations of any type, and you will be free. I will not dictate how you solve the quadratic. If it's factorable, you're free to factor it. If it's not factorable, you may use completing the square, or you may use the quadratic formula. Any method you choose, that's fine. If your answers end up being, for instance, something with a square root of a negative number, if you're using, say, the quadratic formula, you end up that b squared minus 4ac is negative, and you're doing plus or minus the square root of some negative number, then do not leave your answer as the square root of a negative number. Instead, change it to I. So for instance, if you had the square root of -4, the square root of -4 would be 2i, and plus or minus 2i. And if you had the plus or minus, say, the square root of -3, that would be plus or minus the square root of 3 times I. So don't leave a minus sign inside a radical. Change it instead to use I, the imaginary number. Be prepared to solve equations with square roots in them. Like if you had the square root of x plus 7 equals 2x minus 5. And what you do in that case, typically the easiest way to solve those is to square both sides of the equation. and then the square root disappears. You have x's and you have x squareds, yes, but you no longer have a square root of x. And then, as you will recall, anytime you square both sides of the equation, you introduce the possibility of what we call extraneous solutions, which are actually not solutions at all of the original equation. They're solutions to the quadratic equation that was created artificially by squaring both sides of the equation. But then you have to check, when you get done, solve your quadratic equation, get two answers. You're obligated to go back and check both of those answers to see if either one or both of them or neither one is valid. For instance, you might get two answers for the resulting quadratic equation after you square both sides, and you could have one of them good and one of them not good, or both of them good, or neither one of them good. There could be no solution to the equation. That's even possible. So make sure you check your answers and differentiate between the actual valid solutions and the invalid extraneous solutions that are actually not solutions at all. Be prepared to do solve an equation of quadratic type. That's typically where you have one with x to the fourth, x squared, and a constant equal to 0. And there's an excellent example of this in your text. Example 3 on page 201 is an excellent example of solving these equations of quadratic type. Be prepared for something like that. And finally, be prepared to do inequalities. Whether it's a single inequality or a double inequality. A double inequality is where you have two less than signs or two greater than signs. Like you could have -3 is less than or equal to 6x minus 5, which itself is less than or equal to 12, as an example. And remember, to solve inequalities, you can add or subtract the same number to both parts of the inequality if it's a regular inequality, or all three portions of the inequality if it's a double inequality like I was just stating. You can add or subtract any number to all three parts of any double inequality in order to isolate the x in the middle by itself to actually solve it. But if you multiply or divide an inequality, you have to be careful. Because if you multiply or divide an inequality, all the different portions of the inequality, by a positive number, you're fine. The inequality symbols stay the same. But if you multiply or divide any inequality by a negative number, you have to reverse the inequality symbols. And perhaps this is apparent if we consider, for instance, like if you make the simple statement, 2 is less than 3. Not much of an argument over that. 2 is less than 3, but if you multiply both sides by -1, suddenly you have -2 and -3, and now it's no longer true that -2 is less than -3. No, it's more than it. So -2, you reverse the inequality symbol, is greater than -3. That is obvious, but it's just as much true when you have the x's in the inequality. That if you multiply or divide both sides or all three portions of a double inequality by a negative number, you have to reverse inequality symbols. And be prepared also to sketch your solution set for an inequality on a real number line. You can draw your own real number line and sketch your solution. And I'm fine if you want to use, as most of us have been taught to, use the hollow circles and the filled in circles. Use a hollow circle to indicate an endpoint that's not included, and a filled in circle to indicate an endpoint for a number that is included in the solution set. Or you can do like WebAssign does and use the rounded parentheses and the squared off brackets for not including or including the number respectively. It's fine with me either way you wish to do that. But the hollow circles and the filled-in circles are totally fine if you wish to do it that way. And that is a brief synopsis of what you can expect with the midterm exam. I do wish everybody well on this. I hope you have a good appointment for your time. If you don't have an appointment yet, please make your appointment as soon as possible because the times are filling up. We're not the only class doing these proctored midterm exams. There's some other classes too, and the times are filling up. And the worst thing in the world would be to wait till the last day and then there was no time slots available, and that would be a disaster. So don't let yourself get in that situation. And again, I'm sorry the iPad wasn't functional with the PC today, but at least we could have this opportunity for me to help you prepare for the midterm, at least verbally prepare you. So wishing everybody the best on this, and your next assignment after the midterm then will be due next Thursday. That's October 22nd. The next assignment will be due the 3.1 homework and web assignment. You're not seeing it yet, but it'll be up by sometime tomorrow. It'll be up at least by tomorrow, so you'll have a week on that. The first homework, in fact, all the Chapter 3 homework assignments in WebAssign will be up by sometime tomorrow and available to you. So, we're at the midpoint of the course here, and again, I wish everybody the best, and I certainly hope this has been helpful for you. So, wish everybody the best. Okay, this is it here.